Yeah. Hello. Yeah. Hello. Yeah. Good evening. So today we will be discussing this PERT and CPM in IUR. So there are some questions in GATE exam regarding this PERT and CPM. So this would be an important topic for GATE exam. So let us start this basics of PERT and CPM, and let us see how the problem formulation will be there, and then we'll solve some of the GATE questions at the end of the session. So, before PERT and CPM, you might have studied this in your. Okay, you might have studied this in your, undergraduate. Yeah, just a second. Yeah, let us continue. So, you might have well known this PERT and CPM. It is not new topic. So this comes under this whatever you say industrial engineering and operation research. Or management course you can say. So this was not only related to this mechanical engineering, but can be applied to any type of situation where you have a project, different types of projects, and how to plan these projects, and how to trace the project sequence can be done using this PERT and CPM. So these are two different topics, uh, which will, but the main goal is the similar for. So PERT and CPM. So the main goal is project management with scientific techniques. Okay, this is like the project management using this scientific techniques. Okay, so let us start. Before this, we used to have this type of situation. If you are well known with the bar chart or Gantt chart by Henry L. Gard. Okay, so I will draw this Gantt chart so you get an understanding. So this looks quite simple and quite intuitive. So there is no prior background to understand these things. Suppose say you have three projects, namely A, B, C. So this you will arrange according to the the duration. So the y-axis will be time and y-axis will be the tasks. Okay, we have three tasks. So we will arrange this according to the sequence. So 10, 15, 20, and so on. So if you position these things, so this length will be the number of days. Suppose this is 18 days. Something. Just assume this is say 15 days, and this is say 20 days. So this is like a simple representation of task with respect to time. and this is good for future planning. Suppose if there is any projects that are you going to attempt in the coming future, so this is the best representation, which you can see what is the this length of the each project and the duration, you can say, in this scenario. Okay, so now there are some difficulties with this type of representation. I will note down one. I will name some of the difficulties. So one main difficulty is no interdependencies between various activities, so that you cannot trace. So if I say what is the relation between A and B, you cannot say. Suppose can I carry A and B both simultaneously, or which one should I carry first and which other? So there is no such dependencies between these two activities. Okay. The second one is probability of completion is no probability of completion you can get from this uh, simple bar plot, I can say. Then progress. So you cannot at any point there is no just by seeing this bar plot you cannot you cannot make out what is the progress of the current status of my project. So that you cannot get from this simple bar plot, but which is an easier tool. No prior requisite you need, just plot this bar plot. Then comes these two techniques. So one is PERT, the second one is CPM. Okay, so just take a second, take a minute back and just realize what is the full form. If you can remember what is the full form of these two. So I'll just write the second one. I'll write first, which is simple critical path method. It's a critical path method, whereas this PERT is like program evaluation and review technique. Okay. So PERT is like a program evaluation and review technique, whereas CPM is critical path method. Okay. Before I will explain even more these things, but let us proceed with the terminology that we can use. I will use some gap. So no terminology. Okay. So what terminology here? So you will see this type of plots in these exams. Okay. So these are the different. So this is the dotted line. Just okay. So this is a simple project. So there are different things. So we will just name some of these things. So this is sorry. So this is an event, and this is activity, that line. This is dummy activity. Okay, this is the just a simple terminology you can use. So this is the event, and this is the activity, and this is the dummy activity. So if you see dummy activity really does not consume any resource. That is just to establish the relation. We use this dummy activity. That's it. There is no further explanation of the dummy activity. But you should concentrate on this event and activity. Event is like a, this you need to remember. Event is a, it's a point of time. It's a starting point or the ending point of an activity, and it always refers to this point of time. Whereas activity is period of time. Suppose I say this is two, this is seven, this is eight, and this is three. Okay, this is the period of time. So activity is a process which takes place during a period of time. It's a process. Okay, it's an event or activity. Event we talk, this event is an event, and it represents moment of time, whereas activity it represents period of time, or you can say quantitatively an amount of time. Okay, that's it. This is the simple terminology in this. Then let us start with the basic example. Example one. Okay. So I will write this project. You can note it down. Then we'll see how you can proceed ahead. Okay, just note it down. I will explain how to construct a diagram and how to proceed with this. Okay, let's start. Okay. So, so let's start with construction of this diagram first. Okay. So if you see, it is the first activity is A and the last activity is F, and this is the relation you have to follow while constructing this thing. So let me start. I will draw a small diagram. Yeah, this much is enough. Let me start with this. So these, these are activities. A, B, these are activities, and it has a duration. So it should be on the line. So I will start this event. So let me event one. Okay, directly to event two. Okay, this duration is 8 days. Okay, that is activity A. So next, this is the precedence relationship of A for B. So, and it is also for C. So there is a branch coming out from activity 2 like this. Okay, and this is 3, and this is B, and this is 4, and this is C. What is the duration of B? B is 6, C is 4. Okay, so we have done 3 tasks. So now from B we are getting D, and from C we are getting E. Okay, from so it will start from this and from this. But C F is a common node for D and E. So we'll have a event 5. So both are coming like this. You can say from B is D and from C is E. Duration is 3 and 9. And finally, this is F, which has a which is preceded is D and E. So this is the diagram that you should initially construct following this precedence relationship. Huh? Now you need to calculate this critical path. So this critical path is, let me first calculate it, then we'll see what exactly this critical path is and what are the characteristics of this. So now let me start. So now this is the project flow I got, project tree I can say. Now I will start from activity 1 and I will go to activity 6. From this I can get all the things that I missed in bar plot. What is the relationship between different things? What is the probability of completion? And what is the progress of this my current thing? Okay. So now let me start with it. So I will. So for this, there are several things generally followed. Okay. Generally, people used to write a value here, a value here. Okay. There is an activity. You can write like this. Suppose activity 1, and we have two spaces here. So in this space, we used to write earliest, and this is latest. This is earliest and this is latest. Okay, you understand the meaning, right? Earliest and the latest timings. We should, earliest starting time or latest, earliest finishing time. Okay, or this is represented earliest starting time, and this is earliest finishing time at the latest time. Finishing time. Okay. I will explain. Let me calculate it first. So this is the one method. Some people can write one here, and they will write earliest on the top and finishing on the bottom. So this is also, you can follow. There is no hurry. So let me follow this method. Initially, while writing only, you can write like this, so that there will be no confusion. So let me start. So initially, for event 1, there is 0, 0. But for 2, you should write 8 here. I'll zoom it. I hope you can see everything. Eight, you will write 8 here, but you will not write the latest, earliest finishing time, because you don't know. That comes when you count starting from the from the event 6 around. So we leave for time sake, you will leave that. Then you will come to event 3. So you will be adding 6. So 6 plus 18, that is 14. Okay. Similarly for event 4 also, 8 plus 4, 12. Then for event 5, you should 14 plus 9 is 23, and 12 plus 3 is 15. So for earliest starting time, we should take whichever is the biggest one. So that is 23 is bigger. So you take 23 here. Then 23 plus 7 is 30. Okay. The path you followed is 1 to 2, 2 to 3, 3 to 5, 5 to 6. Time you are getting 30. Suppose if you, uh, instead of path, you can say this: A to B, B to D, D to F. This you are getting 30. Whereas if you can follow the other route, other way also, that is A to C, C to E, E to F. This if you do, you will get 22. So this is the least. This is the largest. Okay. So if you, I will leave it to you. Just figure out what if I select 22 instead of 30. What if I say it is only 22, not 30? There will be one task that will be, if you completing 22, so that 8 days work is lost, we can say, because the longest is the minimum time for completion of project. So whatever the time you take less than this will always, you know overestimate your project. So now explain how. So let me calculate this earliest finishing time. So for event 6 it is 30, for event 5 it is 23, because 30 minutes. Then for event 4 it is 23 minus 3, that is 20. Whereas for event 3 it is 23 minus 9, 14. Then 14 minus 6. So here you are getting 14 minus 6, that is 8. And from here you are getting 20 minus 4, that is uh, 16. So for earliest finishing time, we should always take minimum, that is 8. Okay, then here 8 minus 8, 0. So if you underline wherever this earliest finishing and earliest starting are same, so this is the path which is taking the largest time, and this is the critical path, and this is necessary for exactly approximating and project completion. Okay, so this is how you find the critical path in any tree diagram or any project that was given to you. Okay, so now let us see some of the aspects of this critical path. So now, critical path is the longest part of the network. So the longest. And second one is critical path gives the minimum time required for the completion of time. Okay, minimum time required for the project completion. Then the third one is, so those activities which when delayed beyond their expected duration delays the project. So we'll get along the critical path we have critical critical activities. So if you delay any of these activity, the project will be delayed. So that is one of the characteristics of this critical path. And in this also you can say uh, So not non-critical activities are not present in this, critical part. So this is the some of the characteristics of this critical part that we can see. So let us do one more example and see how strong, how well we understood the topic. Okay, let me take one more example. A light on the left and right activities. Okay, so now we just sorry for that. Okay, oh sorry. Okay, now fine. So the activities are A, B, C, D, E, F, G till H we have. So A, so these are the activities. Then president relationships are. And it's G. Okay, and times R, 4, 6, 8, 9, 7, 10, and 3, 5. Okay, let me see. Okay, this is the construct. So now let me this turbine. Okay. Okay, let me construct the diagram now. So now I have total 8 activities that I have to, construct in this manner. So let me start with one activity one. This is the simplest. Okay, let me forgot last time. Let me construct using the method that I earlier discussed. That is, you will try big circle. I think the other method I will use, since it is not visible if I write small letters. So let me proceed with this right now for now. Okay. So activity one, activity A. Let's say this is activity A of 4. Okay. From A we are getting B and C. So from A we are getting B. B is 6. C is 8. Okay. So now if you see from B we have D and E. From B we have D and E. From C we have only F. So now we have B and E. Okay, and from C we have F. So if you see why I have drawn this D below is, so next D and F are joining G. That is the reason that I have kept it here. Okay. So let me write this 5. This is G because D and F are combining G. Whereas E and G, so this E and G they combine to form H. So 4, 5, 6, 7. So this is the construct. Hope you followed. B and C are having A, then E and D are having B, and then F is having C, and D and F are combining, giving two activity Z, whereas E and G are giving combined activity for H. So this is the construct. Let me put the this earliest and starting time. So I am keeping top earlier starting and bottom is the finishing time. So initially it is 0. So now it is here 4. Then 4 plus 6 is 10. Here 4 plus 8 is 12. I forgot to keep the values. So you see E is 7, F is 10, D is 9, and then G is 3, and H is 5. Be correct if there are any values I kept wrong. So now you have this 10, then so you can directly go for 6? No, because we cannot go 6 because we have another route also, that is CFG. Okay. So now if you can, if you see at junction 5, that is the activity event 5, we are getting D as well as F. So if we have 10 plus 9, that is 19, whereas 12 plus 10, that is 22. So we have to give the highest 22. So now 22 plus 3, we are getting 25 here, whereas 10 plus 7, we are getting 17 from this route. So 22 plus 3, we have 25 plus 5, we have 30. Okay, so you need to highlight this because this is the highest, uh, longest duration of the project. Then, so now let me put this earliest finishing time as well. Then you can understand. So let me come from the end, that is 30 minus 5 is the 25. Then we should not go for in the E route, rather we have to go from the Z route. Let us see what happens. 25 minus 22. So 25 minus 3 is 22. Whereas now you see at junction 3 what happens. Because this 22, we are getting 22 minus 10 is, okay, 12. 12 minus 8 is 4, 0. Okay. Now at 3, if you see 25 minus 7, you are getting 18. Okay. Whereas from other route, you are getting 22 minus 8. You should take the minimum, whichever is minimum, that you should take. Whereas while area starting, you should take the maximum. Okay, 18 and 13, so 13. So 10 and 13. So if you see this area starting and area finishing time, if they sum up, if you subtract one on each other, if they are getting 0, that is the critical path. And you can highlight this easily. Okay, so this is the critical path, which is A, C, F, G, H, summing up to 30 days. Whereas there is one sum of activities such as B and E are non-critical activities, if you see. But the rest are, uh, these are the critical, rest are critical activities. If you delay any one of the activity, you will get, the project get delayed. Okay. I think you got some confidence in constructing this type of figures. So these are some of the examples you can see easily. So now I will give you a simple example that you can solve yourself. Then we'll proceed with the start the class. So now see, this is a homework, you can say. Please note it down and take a screenshot and solve it. Should solve it very carefully. So this is a tricky problem I have given. So don't be in a hurry while solving these type of questions. These are easy. They can give more easier but longer path. So it consumes time, but if you spend some good amount of time, you'll easily get answers. So these are not the tough questions. Okay. So let me proceed with this difference between this PERT and CPM. Okay. So PERT is event oriented, whereas let me write this by CPM. Sorry, activity oriented. Okay. So then, PERT is concerned only with the time, while CPM is the time and cost both. Oh, sorry. Let me write first. Only time it is concerned. So time durations are probabilistic. We need past data for PERT. Examples such as R&Ds, ISRO, etc. Okay, now let me write this CPM. So this is concerned with time and as well as cost. These are deterministic. Whereas this is for commercial projects such as L&T, Tata, etc. So this is the comparison you can draw from this PERT and CPM. Okay. So let us solve some of the questions regarding this simple basic PERT and CPM in GATE exam. Okay. This is the first question. So what is the distribution? What is the distribution of the activity in times assumed in PERT? What is it? The distribution is always the normal distribution we assume in PERT. Okay. So I have just explained you how to do simple tree diagrams. There are more to learn in this. I will explain a bit in the next class. Let us solve with this simple knowledge. You can solve most of the questions in this activity. Let us proceed. So this thing I didn't explain. So what is the PERT activity? It is simply this one. So we have this expected time is optimistic, most likely pessimistic by 6. Okay. I'll explain the term. Optimistic time is like everything when everything goes according to the plan. Whereas pessimistic is when nothing goes according to the plan. And most likely, is like in between these optimistic and pessimistic. And TE is the expected. Okay, so this is how we estimate in PERT activity. The critical activity has, remember, it has always have zero plot in PERT. So now this is the question. So this is the type of questions I want to you guys to explore and solve easily. Okay. So this is what we are also discussing. So they are not asking you. See the tricky minimum project completion time is the longest path. Just remember that. Don't make mistakes in this. So this is nothing but the time duration in critical part. Okay. So see the activity as well as the this procedure relationship while constructing this tree diagram. So let me start. So first, one, it is activity A with 4. Then 2. So from A we are getting both B and C. So I will not write this activities first of all. Let me explore this. Then from B and C we are getting D and E, and from D and E is like. So this is a simple, 3, 4, B and C, 3 and 7. Okay. This was similar to what I explained in the starting. Okay. So now, if you see this minimum project completion time, just you can directly calculate this. There are only two routes. One is A, B, D, F. The other one is A, C, E, F. So these are the two routes available. You can just place the values. So 4, 3, 14, 9, whereas 4, 7, 4, 9. So ultimately you are getting this as the longest one. So this, okay, this is the minimum project completion time, that is right. Okay, in this they're asking you minimum. So generally minimum project completion is the critical part, but in this question they're asking you different way. If there is no these things, then you can directly write 30 here. But they have provided you with this, so 24 will be the minimum value. But 24 will not be the case, is not the completion time, because longest path is what completion time. Otherwise, some project, some task will lose its this duration. I hope you are clear with this. It's a tricky question, so that's why the options are not the 30 is the correct answer, but the options they provided 24 is the correct answer. Let me move to the next one. So they have given you the tree diagrams and they are asking minimum times. Now you have to, so actually the both answers are correct in this question, but you should always give the longest critical path is a minimum time for completion of the project. So now, so let me start with, so here we have, see, if you see, we have 1, 3, 5, 6 is one route, 1, 2, 5, 6, one route, 1, 2, 4, 5, 6 is another. So we have total 3 routes. Okay, let me start with first. So 0, 0 plus 12, 12, 12 plus 7, I cannot come. I will come in the next way. That is 0 plus 14, that is 14. So now we have 14 plus 12. 12 plus 11 is 23. 14 plus 12 is 26. Now see from come here. 14 plus 7 is 21 plus 9 is 30. So 30 is the highest. Then 30 plus 1 is 40. Let me come from the other side. It is 40. 40 minus 10 is 30. 30 minus 9 is 21. 20 minus 9 is 14. But you should see the other root. So that is 30 minus 12, which is 18. So 14 we should take. Now, if you see this activity 3, 30 minus 11, there's only one. So 30 minus 11 is 19 and 0. So now if you underline 0 flag 10 activities, okay, this is one, that is 1, 2, 4, 5, 6, which is giving 40, and you have one more root, which is 1, 2, 5 and 6. This is also giving you 40. So we have two critical paths in this. This is also critical path, because starting ending we have the same. We have two critical paths and we have, but the duration is 40. No, see, sorry. Sorry. So this is not the critical part. Because if you see 16 plus this 30 minus 12 will not end up in 14. So this is the only root that you can follow. So this is not the critical path, this is the critical path, and answer is 40 days. So this I want to explain you. Just see the question mark. Okay. So let me zoom it a bit. It looks a little, a complex tree. It's for 2 marks. So if you spend enough 3 minutes on this, you will easily get the answer. Just since it's a big one, so you cannot make out quickly. So if you see, there are several uh, paths. So one thing I will try here. 1 to 2, 2 to 3, 3 to 10. This is one. Then this is one more. This is one more. This is one more. So total 4 routes we have. Just if we can. So now is they are not asking the completion time initially at node 10. This one. What is the latest finishing time? Okay. So if you can calculate, simply calculate this time for these 4 routes instead of doing all these things, and then you can just come reverse. You can easily get this answer. So that is one quick way. Let us try. Uh, so first route is second route is, I think better we write this activity names. It will be easier. So first one is A to B, B to E, E to M, M to N. The second one is E to C, C to F, F to J, J to K, K to L, L to N. The third one is A to C, C to D, D to I, sorry, G, A to C, C to Z, Z to I to L, L to N. And the fourth one is A to D, H, L and N. Okay, now see A is 2, uh, B is 3, E is 4, M is 3, and N is 2. Then C is 4 and D is 2. Then F is 2, then G is 4, then J is 2, K is 3, L is 2, then I is 5. So here I missed L, I think. A, C, G, I, L. Yes, L is 2. So it has common na L. This. Then H is 4. Just check if I missed anything, then we can proceed. So first is A, B, E, M, N. Second one is A, C, F, G, H, K, L, N. The third one is A, P, A, C, G, I, L, N. Okay. Then finally is A, D, H, L, N. So if you sum these up, so 2 plus 3, 5, 5 plus 2, 9, 9 plus 3, 12 plus 2, 14. So this is coming up to 14. So this is 2 plus 4, 6, 6 plus 10, 13, 13 plus 4, 17. So here 2 plus 4, 6, 10, 15, 16, 17, 18, 19. And this is 2 plus 2, 4, 4 plus 4, 8, 8, 10, 12. Okay, you can count one more. 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. Then 2 plus 4 6, 10, 13, 13 plus 4 is 4, 17. Here 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 4 is 19. Okay, the last one is 6, 4 plus 4, 8, 10, 12. So this is the critical path, which is the longest. So 19. So okay. So 19 minus 2 is 17. Here also 17. So both will come 17. You don't need to worry because it's the highest at the bottom. So now if you come to the node 10, it is 17 minus 3. So nothing is connecting it. It is 14. Okay. So that this is one of the simpler way that we can solve this type of questions. Or else, if you follow the previous method like this, it takes more time. You can try it and see. I prefer this simple method only for this type of questions. If there are more number of activities involved, so I prefer this. This is the one of the simpler way to solve this type of questions. Okay. If you feel this method is comfortable, you can always go for it. Since I see more number of activities, so there is very good chance of committing small mistakes. So this method I prefer easier because in this activity there is no connected activity for 10. It is completely free. So that is the reason why I chosen it. Otherwise, if there is anything connecting in this way, then I have to solve using the previous method. Okay. So this is a shortcut only for these type of questions. You should see whether the think that suppose if instead of 10, what if they ask 4, then you have to solve using the previous methodology. Even, so 10, 9 are the, notes that they can ask. Even 3 also they can ask. But apart from that, if they ask anything, then you have to solve completely all the, every node like in the previous thing. Okay. Okay. If there are any properties that are related, I can. There are more things I didn't start because it's too big, so that I reserved it for the next class. So where we talk about the probability of the completion, what is the slack time, what is the float, what is crashing, what are the assumptions that we use while this tree construction or the network connection. There are a lot to find. For simple, I can end with this small, topic, and then we can meet in the next class. Okay. So we have two boxes, right? Earlier starting and latest finishing time for each activity. Say for for an activity, this is DIJ is the duration. So now, so there are certain parameters that you need to consider. So one is the total float. So this is the total float. That is EI plus DJ minus LI. Okay. NJ minus EI minus DIJ. Okay. This L minus DDI minus EI. Whereas this free float, this is free float. Okay. And one more is the independent float. Okay. So these are the different timings uh, available, so that the procedure or the next activity will not be affected. So this is the one activity, one event. This is the other event. So the next event two will not be get affected by one. So that is the basic thing lying behind these types of flows. So this is just a diagram that you can remember. I will explain you. This is just if they give this two nodes. Suppose for event one, I have say 7, 10, with a duration of 5, and event two I have say some 7 plus 5 always 15. Then I have some 17 here. 17 minus 5 is 50. Okay, this is the timings I have available in my network. So now if I want to, what is the total float? So total float is nothing but 17 minus 5 minus 7. That is the total float. So free float is nothing but 15 minus 5 minus 7. What is the independent float? 15 minus 5 minus 15. I think here, I just randomly pick the values, but these are the values that you get. Okay. So this is just an introduction I just gave you. Uh, Simply, instead of taking these, difficult values, you can take a simple value for explanation. Suppose you have 006 and you have 6 per event. Now, if you want to calculate, so total float will be 6 minus 6, 0, and free float is 0, whereas independent float is 0. Okay. Suppose for similar, if I take 12, 22 with duration of 2 and 27, 27. So in this also case also you will get similar float values. So this is how you just calculate. I will explain you what is the meaning of this float and how this affect the the previous events. I just gave you the concept. So this is what you need to remember for example. So they can just give the values like this and they will just ask what is the total float, what is free float, what is. With this, I will stop here. We will meet in the next session. We will complete this CPM part and CPM, and we will start this little bit of transportation. And we will end the sessions from there. Thanks.